Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 26, 2025, about 2 days ago. It shows that a small 8 billion parameter orchestrator model can beat a giant system like GPT-5 on very hard exams, scoring about 37% versus 35% on humanities' last exam, while being roughly 2.5 times more cost-efficient. The paper is titled ToolOrchestra, Elevating Intelligence via Efficient Model and Tool Orchestration. And as we will see later, the implications for how we design tool using agents are quite significant. Alright, the introduction just laid out the promise of a small orchestrator beating heavyweight models on tough exams. Figure 1 turns that claim into numbers, showing bar charts where the 8 billion parameter orchestrator scores highest on humanities' last exam, frames, and Tau2 bench. The right panel plots accuracy versus dollar cost, and the orchestrator curve sits above the others, so it delivers more accuracy for each dollar spent. Together, these plots argue that smart tool coordination beats sheer model size. So, while Figure 1 gave the headline numbers, Figure 2 explains how the orchestrator actually works. The user provides a query plus a preference such as wanting cost efficiency, and the orchestrator alternates between reasoning steps and tool calls across multiple turns. The central panel lists 3 tool families, from cheap basic utilities to specialized and generalist language models that become increasingly expensive. On the right, the green box shows that reinforcement learning trains the orchestrator with a combined reward for outcome accuracy, efficiency, and matching user preferences. So while Figure 2 described how reinforcement learning shapes the orchestrator's behavior, Figure 4 shows how the training data itself gets created. The process starts from a domain such as movie booking. Then a language model invents a database, schema, and realistic tools like cancel or refund, which simulate an environment. Another language model samples user intentions over specific database rows and turns them into concrete task instructions plus golden tool call sequences. This synthetic pipeline provides rich, verifiable trajectories, so the orchestrator can practice multi-step tool use at scale. Alright, the synthetic pipeline just explained how the orchestrator learns. Table 1 shows what that buys in practice. The bottom row reports Orchestrator 8B, scoring about 37% on humanities' last exam, 76% on frames, and 80% on Tau2 bench. Those scores beat all prompt-based baselines, while averaging only about 9 cents and 8 minutes per task, so the small orchestrator delivers both higher accuracy and far better efficiency. Well, Table 1 compared overall scores and costs, and Figure 5 now shows how different controllers actually spend their tool budget. The first 3 pies reveal heavy dependence on a single model, like QN235B leaning on one tool for over 40% of calls, and Claude Opus passing almost everything to GPT-5. The rightmost pie for Orchestrator 8B spreads calls much more evenly across models, search, and code tools, which explains how it achieves strong accuracy without runaway cost. Alright, the big message is that a small, reinforcement learning trained orchestrator can outperform a giant model by smartly choosing among tools, not by sheer scale, and it does so at a fraction of the cost. That points to future AI systems as flexible tool conductors, not single monoliths. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.